Hello and welcome to European Microwave in Berlin. We're excited to team up with AMCAD Engineering and Mori Microwave to present something genuinely innovative in the realm of semiconductor testing.
Hi, it's Maxime from AMCAD Engineering, and I am in live at European Microwave Week.
Maxime, thank you. Could you walk us through the core innovation that sets AMCAD's dual pulse measurement technique apart?
The core innovation of the dual pulse measurement is to measure an IV network by defining dynamically the charge trapping state by using a specific condition. If we take an example of a device that is used with a wideband signal, the transistor will go through different trapping states. So, to do so, we use a VNA-based Load Pull system where we apply the calibrated pre-RF pulse and measure an IV network.
Considering AMCAD's extensive background in device modeling, how do you see this pre-RF pulse IV measurement technique influencing the future of RF Power Amplifier design?
The pre-RF pulse IV measurement directly takes into account the trapping effect. As it's measured on specific load condition, it's very close to the final application and so close to the RF Power Amplifier design's need.
Could you elaborate on how the VNA-based Load Pull system, in conjunction with the AMCAD pulsed IV generator, enhances the accuracy of these tests?
The pre-RF pulse, as all traps model, need to be done on quasi-isothermal condition. So that's why we use an AMCAD PIV system in order to generate and measure very short pulses, and the combination with the VNA-based Load Pull will permit to do the measurements on a specific load condition with a specific RF level.
Many people find the concept of charge trapping state intriguing yet complex. Could you simplify it for our audience?
The trapping effects are inherent to GaN HEMT technologies. The trap phenomena are induced by DC and RF signal applied to the device, and the electrons are trapped and released directly and will directly affect the current conduction.
This demo system is running on a TS2000 IFE from MPI Corporation and is fully automated with Sentio and IVCAD. How has this impacted the overall usability and efficiency of this AMCAD solution?
Sentio, in combination with IVCAD, will permit to speed and improve the measurement extraction. The good stability of the probe station and the probe integration will permit to apply very narrow pulse and do measurement with a very good quality.
Can you share any practical application or case studies where this technique has shown measurable benefits?
The pre-RF pulse measurement techniques will permit to take into account the dynamic trap effects. So it doesn't need trap model. We have done the job to extract a compact model using the two solutions, the classic method, but using a trap model, and the second one without trap model using pre-RF pulse measurements. And we've seen a time benefit of 30% to extract the model with comparable performances.
What kind of feedback have you received from engineers or researchers who have used this new method?
As far as this method is quite new, our customers say that this measurement technique is very interesting because it uses exactly the same instrument that already have in the lab, because we use VNA, a pulse IV system, that is instrument that is necessary to use when you extract the measurement to do compact model. Moreover, this measurement technique permits to highlight very fastly the trapping effects on the device measured. Thanks for your attention.
Now, Maxime, could you give us a bit more information on this advanced integration?
Yes. When you want to do IV measurement or load pull measurement to extract a compact model on GaN HEMT technologies, it's necessary to do the measurement on quasi-isothermal condition. So this integration permits to put the bias T and the tuner very close to the DUT, so we can reduce the length of the pulse in order to apply very narrow pulse and so reduce the thermal effects, and put the tuner very close to higher the gamma on the probe plane, and so surround the output power and maximum efficiency. So here you can see the new IVCAD module that will permit to configure the pre-RF pulse measurements. So on one side here, you can import your load pull measurements that will permit to choose the load condition where you want to extract your pre-RF pulse measurements. When you choose the right load condition, you can go to measurement settings in order to configure the IV network that you want to do. When you click on more, you can see directly all the points that will be down on the pre-RF pulse measurement, and when you choose one point, you can see directly the chronogram associated to the point selected. In order to automate the measurement using IVCAD, it's necessary to do the waveform mapping through Sentio. As you can see on this video, we have done a waveform mapping using Sentio, where we check the compatibility, and you can see we can move fastly and easily to each die. For more information, don't hesitate to visit our website on www.amcad-engineering.com.